Hello and welcome to another Elastic Community virtual meetup. My name is Olivia and I am on the Elastic Community team. I'm joined today by Enrique Kortright. He is a education architect here at Elastic. He'll be presenting on Schema-on-Read. So if you have any questions, feel free to post those in the chat and we'll have some time at the end to answer that. I also want to mention if you are interested in presenting at one of our virtual meetups or in-person meetups, feel free to reach out to meetups@elastic.co. We'd love to chat with you more. With that, let me turn it over to Enrique.
Hello, everybody. Welcome. I'm pretty excited to be here. I've done a few meetups in the past, and they're always a lot of fun. So feel free to ask questions. We'll try to get to them at the end, and maybe I can even answer them. So the topic for today is Schema-on-Read, which is what Runtime Fields will add to Elasticsearch. And it's a very exciting topic. There are some trade-offs, but we're going to get a lot of flexibility when we use them. So they're not for every use case, but whenever you have certain issues with your data, and it's going to provide a real option. So let me see how my slides are doing. All right. So as Olivia said, make sure you join your Elastic user group so that you can join in-person and virtual meetings like this one. And also don't forget that we have a contributor program, and you can join that so you can contribute to Elastic. And the top contributors get some really cool things. So that's a great option if you've been doing demos and you have some ideas, you have some slides, you just want to review content. So participate, and it makes us all better. So, all right. So this is what we are going to do today. We're going to talk about what is a runtime field and what is this all about. Schema-on-Read, what is that all about? To actually develop runtime fields, we're going to need a scripting language. And Elasticsearch has its very own scripting language called Painless. Some people think that's funny. No, it is a real name, and to me, it is actually painless. Other people will object to that. They'll say it's very painful. I don't really think so. But you do need to write code. So some people just say I don't write code. Well, then you're going to have a problem developing runtime fields, just like you would have if you were developing a watch or something for Elasticsearch. Then we're going to look at some use cases. I mean, they're not all the use cases you can address with runtime fields, but they're pretty representative and they're fun. So those I will mostly demo, and then we'll come back to the theory side and talk about what is the cost, what is the trade-off, and maybe some best practices at the end. This is a new technology, so it has been changing. Some things that I'm going to show you right now may not actually work for you unless you're on the very latest version. And some things that are upcoming, I did not even include because they're tagged as experimental, so I didn't want to get into them yet. However, as I will mention in the last slide, I am working on a course that will be available on demand, where we'll go deeper into runtime fields with more use cases and tons of downloadable code. And our courses do have hands-on labs, so if you want to practice, it's make sure you keep an eye out for the course when it comes out. All right, so what is a runtime field? Well, back to the beginning. So Elasticsearch is a store for JSON, so it stores JSON documents. And those JSON documents are grouped into indices. So if you think of a database has tables and rows. We have indices and documents. Now, Elasticsearch is not schema-less. In fact, it does have a schema. Every index has a schema. The schema is created either by the data modeler, or if you just store data in Elasticsearch, Elasticsearch actually dynamically generates the schema for you, but there is always a schema. Okay, so either because you're writing data in an index or because you define the index ahead of time, you are developing your schema on write. Okay, it's available for whenever you write. Now, there are some issues with that. First of all, we don't have a join operator. So you don't do joins between indices as you do between tables in a database. So that means that for us to have the data that is needed to support a use case like a search page or something like that, we have to denormalize the data. Of course, you know, if you're a database person, denormalization creates a whole bunch of problems. You know, not the slightest one being that then you end up with tons of fields in a single container, you know, in a single index in our case. So that mapping explosion, sometimes, you know, we tell people, you know, be aware of it. But on the other hand, some of our own indices have thousands of fields. And then every field is going to require some storage. And then if you plan to search on it, it'll require some supporting data structures to be generated. So if you're talking about hundreds of fields, which is pretty common, to thousands of fields, which is not unthinkable, you are going to create a pretty decent storage requirement. So runtime fields are a solution to these two problems and some additional ones. Because a runtime field doesn't really exist in an index. It's created at runtime, as the name implies. So whenever you need the field, Elasticsearch will create it for you and then will treat it as if it were a field in the schema. So that's why this is called Schema-on-Read. So for all intents and purposes, a runtime field is just a regular field. You can use it in queries, you can use it in aggregations, you can use it for sorting. You can use it to correct the data if you want to. You can use it for data exploration. However, in all the things that I said, the field is still not in the schema, and physically, except when it's being used, it's not being stored. So you don't get all this for nothing, right? So what is the trade-off? Well, you're going to get the space savings, faster ingestion because you're not storing as many fields. You still have them in the data set, but you're not generating data structures that support them. So you're saving a good amount of space, and you're also ingesting faster. So you're going to get more flexibility, functionality, but the performance is where you're going to take a hit. So as you know, performance is a big thing for us. So most of the time, you will not be using runtime fields, right? They will be used only when you need them for specific reasons. They are a great tool, but you need to understand that there is a trade-off. So, all right. So what are some use cases? Well, let's say you decided not to index a field because you wanted the space savings and the faster ingest time. Well, what if you need it? Well, you create a runtime field, and that just copies it from the source, which is where the original document was stored. I mean, we always keep a copy of the original document. So you can use a runtime field to turn that stored document field in source and promote it to an actual real schema level field. You can take a field that in your data that no one's structured, like for example, the message in an index or a long string that has a lot of content in it. So you can use a runtime field to parse it with a parser like Grok and turn it into runtime fields for a use case for data exploration. Or you might need a field that people just didn't even think about. You have existing data and you need to do a calculated field like we do in databases. So you can also add new fields. And the beauty of that is, if you remember, when you add a new field to a mapping in plain old indices, you have to hydrate the field by doing an update by query or a reindex. We don't need to do that with a runtime field. And then the last one that I want to talk about today is what if the data is wrong? Well, you can actually use a runtime field to layer on top of the real field and override the value and even the type. Now, all of these, again, there are trade-offs. Sometimes there are consequences that you might not intend. So hopefully I will take you through some of that. Now, you may be aware of older technologies like script fields, script queries, or filters, and script sorts. So unless you have a strong reason to use any of these, because you don't want the field, Runtime fields are better because they are real fields at the schema level, and the performance is about the same. I mean, they both require scripts. The script is where the bottleneck might be, and we're going to talk about, let's write maybe more efficient code so that our runtime fields are more practical. How do you create a runtime field? Well, you have three opportunities. One is, let's say you need it in a use case. So you do a search, and the search needs a field that is not in the schema. Well, you can do that as part of the search. Let's say several searches and aggregations, and then Kibana, they need that runtime field. So it's not really part of a search. It's just a field that we want to keep as runtime, but we kind of want to have it in the mapping. So we can actually add it as a runtime field in the mapping. So that means it's physically still not there, but it is part of the mapping. It still needs to be computed at runtime, but for all practical, logically, it's a field in the mapping, and then you don't need to declare it in every search. And then there's a third way, but it really is not a third way. You can define the runtime field in a Kibana data view, but it's just a shortcut for a runtime field in a search. So you can tell Kibana, here's a field for you. This is how it's calculated. And then Kibana will say, okay, well, when I need it, I'll include it in my request to Elasticsearch for data. So there's really only two ways. Kibana uses one of them. All right, so unless you're just pulling data from the source, in which you don't need a script, you are going to need to write some, a minimum level of scripting, or maybe a lot of scripting. And we have a language for that called Painless. And the Painless language was developed specifically for Elasticsearch. I think the pain reduction was because when we had other languages available, there were quite a few hacking incidents that made the news, and it was for many different reasons. But one of them was our door through scripting was maybe too open. So we closed it by developing a language that is safe and secure. It's also fast. The syntax is actually simpler than it's a very friendly syntax. I mean, I like it, but the power is just as much as Java, because we are exposing Java APIs for your script. So if you want to regenerate a random number, or if you want to multiply by times pi, and you know that those are in the math library in Java, you will be able to use that. Maybe more practical would be date APIs in Java, string APIs in Java, and some data structures like maps and array lists. So they all come from that. So whether you like it or not, that's the only procedural language you will have available. So if you want to do runtime fields, there really is no choice. You have to use it. Now, how do you use it? Well, when you declare a runtime field in the two ways that I talked about and that I'm going to demonstrate, you are going to use the emit function to assign a value to the field. So this is like in a function we normally use a return statement. For a runtime field, one difference is that we need to use emit. Yeah, minor difference. Now you can write any code you want, right? But it will be evaluated every time you need the field on every document. So if you have a search that involves a lot of documents and they all need that field calculated, the script is run each and every time, because every document is a new input to the script. So when you took computer science and you learned about time and space complexity, big O notation, and all that, they were actually important lessons that we may not have thought at the time. What is all this theory all about? Who cares as long as the algorithm works, as long as it compiles. Well, no, now we're in the real world. This is big data. We don't want to lose efficiency. So yeah, the fastest algorithm is definitely what you're after. Absolutely. And also space. I mean, you don't want an algorithm that is recursive, that will use an activation stack that will use up all the heap space, because the node needs it. The node needs that heap space. And there's no bound on what a painless function can use in the heap. And as far as I know, there are not even circuit breakers for recursion levels. So yeah, be very careful. I mean, you're writing code, okay? Now, if you want to do it in a search, you use the runtime mappings clause. Very soon we're going to jump into some demonstrations and put all this together. But it's, usually it's using the right clause either in the mapping or the search. You have to name the field and you have to indicate the type. Text fields are not supported. Okay, we don't want to use a runtime field of type text. That is very complex and probably very slow. So we don't want to get into that. Okay, so you have things like keywords and numbers and geopoints. So for the most part, it's the kind of the derived fields that you would want to have not indexed. Okay, and then you write a script that figures out the value. Maybe it's just field 1 times field 2. That's fine. And then you need to use emit. If you add it to a mapping, the only thing that changes is the clause. In this case, it's not a runtime mapping. It's actually a runtime clause in the mapping, but the rest is the same. In fact, you can port the script from the search and put it in the mapping, and that's all you need to do. And in Kibana, if you define the field in the Elasticsearch mapping, Kibana will see it as any field. It won't even know that it's a runtime field. Except there are some glitches which in older versions, not the most recent ones, will actually break some things. But in the newer versions, it seems to work just like I just said. Kibana will not know that field is not real. And on top of that, Kibana can add its own runtime fields using the data view, which, as I mentioned earlier, they will be actually added as part of a query back to Elasticsearch. All of this I will show you how it works. So I think the best thing to do is to just jump into a few examples. So let me tell you what the examples are going to be, and then I'll just from here on work on code, and then we'll come back to just remind you of some very good bits of advice on performance and best practices, so you don't forget about them. So the first example, I am going to take a field that we decided not to index because we were going to save the space, but then we find out on a search we need it, so we're going to promote it from the source. Okay, that's example 1. Example 2 is we find that the indexing created a field that is not usable because the type is wrong. In our case, it might be because the value is wrong. The values, you may decide the values are too low. Somebody should have multiplied them by 2. So you create a runtime field that takes every value, every existing value, and multiplies it by 2. So you can do that. The data we're going to use comes from one of the documentation pages, which I really like. It's a few locations of museums in Europe. And what we're going to do is we're going to index it without setting up an index ahead of time. So the point string is not going to be captured as a geopoint. It's going to be captured as a string, which means our geo functionality for finding distances between 2 geopoints or putting the data on a map is broken, right? It won't work because it's not of the right type. So we're going to fix that using a runtime field. And then the last one is when we need a new field from existing data. So we have all sorts of data, and we want to create a field that we don't have. It's a derived field. And the data I'm going to give you is actually one that you would want to probably use a runtime field for because it's nested objects, which are always problematic for Elasticsearch. So what we have is a class with students in it. And for every student, we have the name and the homeworks they did and what grades they got and the exams they took and the grades they got. And then the instructor wants to run a query, run a search, and figure out what is the grade, numeric and the letter grade. But the thing that they want to do is they want to be fair. They want to, based on the performance, they want to come up with a grading scale that is just so, with including weights and letter thresholds. And I know that it should be in the syllabus, and instructors should not change the syllabus unless it's for the better. But the instructor wants to be able to do simulations until the instructor reaches the final decision on how the grades are going to be. Maybe give everybody A's or fail everybody, depending on the mood. So that's the three examples. So we'll come back and revisit the performance considerations, but right now I want to solve some problems. So example 1, we have an index with people in it, and we decided that we want to capture the name. We only have 2 fields, but we want some real space savings. So I want to save 50% of the space by disabling the second field, which is building. That's where they work. So the building field is disabled, but we still have it in the stored source, but we won't be able to search and aggregate on it because we disabled it. So let's go ahead and create that. So I'm going to start from scratch. So I'm going to create the index, and then I'm going to put some people in it. It's going to put Jane and John and Sam. Okay. So, I mean, my data is there. It's fine. So, if I do a get on people and I do a search, all the data is exactly as I had it. So I have the stored field. But what I cannot do is ask a question like, who works in building? In fact, the autocomplete doesn't even know that a building field exists. Now, the autocomplete is broken in more ways than one. But if I ask for this, it says no one works in that building, because we said that the building field is disabled, which means there was no inverted index, there were no dog values. So it's not available for searching. It is also not available for aggregation. So I couldn't do like a terms aggregation to group all the people by building. I cannot do that. Okay. But the solution with a runtime field is simple and elegant. All I need to say is which field I want to retrieve from the source, what type I want to give it to you. So that's why we call this one Schema-on-Read. And then I always need a script, but in this case, I don't really need any code. Now I always write I always say that it's a Painless script, which is kind of strange because that's the only language we can use. But that may not be true all the time. Okay, a lot of people say put Python back. So that may change. So for that reason, I document every script that I ever write. And but in this case, we don't need a script. We're just promoting a value. So in fact, in this case, I think all we need to do is say, just bring me back that field, right? So now it says, oh, well, Sam works there. Well, you didn't tell me that before. Well, because there was no field called building, but now there is. So where did the data come from? It came from source. So now I can also do something like this. I can say, people, I can do a search, and I can do an aggregation. So now, by building, and I can do a terms aggregation on the building field very easily, right? I can do that. Let me set the size to 0 just so that you see the buckets. And then it says, well, there are no people in any buildings. Well, why? Well, because the field doesn't really exist. But in the search, you could use it. Well, because I added it to the search. So we have 2 choices. We can say, well, just copy the runtime mappings clause to the search for the aggregation. Or if you're going to be doing this a lot, you can actually put it in the mapping. So let's do that. Let's go to the mapping and then put in let's copy the entire runtime mappings clause. So I'm just going to copy it from here to here. I'm going to get rid of that comma, make it be a runtime, and then add it to the mapping. And now I should be able to aggregate and get my my buckets. So it's the same aggregation that was not working a moment ago. I added a runtime field. Now I didn't need to re-index or do anything like that. I did effectively add a field that I can work with, but it's costing me because every time that I run it, it's going to source and pulling the data, going to source, pulling the data. So this is the lightest weight case in which all I want is data that is stored, but is not a real field. So this makes it a real field. It's very convenient. If you go to Kibana, You can even create a data view now that we have it in the mapping. So let's create a data view called people. So that will be people. And then we will see it here. So there's the people data view that has building that doesn't actually exist physically in the schema, but it does exist in the as a runtime field. So this is not a Kibana field. This is a field that we defined in the Elasticsearch side, and it's a field in the runtime section of the mapping of the people index. Now I can do aggregations like I can do like visualizations, like I can go to Lens and say, you know what, I want to visualize who is in every building. So I can come here and it says, okay, you want to visualize by building. So life is fine. I mean, it's like Kibana says, I don't know if that's a expensive field or not. All I know is that it works. Until somebody says, you know what, we don't want it anymore. So let's remove it from the mapping. Okay, well, that, as you can imagine, that one will have consequences on, so you remove it. You just say, set it to null. Now it's gone. Okay, so the poor users of Kibana, when they refresh, they say there's no data. Well, there was data just a moment ago. I'm pretty sure we had 2 bars, one for each building, that told us how many people work in each building. And now it's like, I just refreshed. So did I do something? Says the Kibana analyst. The answer is no, you didn't do anything. We did it all on the Elasticsearch side. So yeah, you can actually break Kibana by playing undisciplined games behind the scenes. So don't give the Kibana users a field that you don't intend to keep, because if they build aggregations, if they build visualizations and they put them on dashboards, and then you change your mind, you're going to break things. Okay, so that's example 1. Now, for example 2, what I have is, I think we pretty much did all this. For example 2, I have museums in Europe. Okay? This, like I said, is in the Centroid aggregation documentation, but I just like this example a lot. So these are museums. So I'm not setting up the index ahead of time. So I'm just going to ingest data. And then I realized later that I have a problem, because in the mapping, the location ended up as a string, not even as numbers. It's just a string, right? It says point, space, parenthesis, and then some numbers. So that's a really, now it's a valid string if we had set in the schema of the index location to be of type geopoint, Elasticsearch would actually accept that format. But you could make the problem even worse. Maybe somebody called this one location, in which case even Elasticsearch is not going to help you there. Okay, so that's the situation. We have an index with the wrong type in a field that is going to prevent me from doing this. So let me go ahead and let's see, what do I have in the mappings? Okay, so let me try to do this search. And why is this one even working? Did I delete it? I don't know if I deleted it. I'm going to delete it. I am going to rerun it, and then I'm going to do a search looking for an aggregation that is supposed to fail. These demos don't always do what you want them to, because the location is not in the mapping as a geopoint. So somehow, oh, I know what's happening. It is being accepted as a geopoint in this version of Elasticsearch. So I think it's being recognized as that. So let me just change it. I'm going to change it to location. And I'm pretty sure I tested this. This may not be the only problem I have. And I've tested these demos, 4 times. But okay, so let me try again. And I won't spend a lot of time, so I can explain to you what's supposed to happen and what did happen and what didn't. All right, so I'm ingesting the data, and then I look at the mapping for museums, and it is museum spelled right. And now I'm trying to do a geo aggregation, and it says yeah, there's a cache script somewhere that is not being deleted. So let me do this. Okay, so let me reingest it. Mapping. Yeah, well, okay. So the error that's supposed to happen that did not happen, and let me see if I can get it back by just calling it something else. Is that the field is not correct? But I think I probably broke too many things when I was testing this. I have ingested my data. Now the mapping says location is text and so on. And I want to do a centroid aggregation on museums too. And I don't know, I'm doing something wrong. And oh, no. This is what I'm doing. Sorry about that. Okay, everything's fine. Okay. I had the solution in the problem that I want to show you before I solve it. So I had like a half-baked solution. So anyway, so here we are. We have we're trying to do an aggregation on a field location that is of type text, and it says, well, you cannot use. First of all, you can't use text fields for aggregation. So I say, okay, well, the keyword version is not going to save us because the geocentroid aggregation does not work on a keyword field. It only works on a geopoint field. Okay. So what I need to do is I need to override the field location, give it the right type. And I am going to do that right now. So I'm going to say, let's do that. We know we have a field called location. So in this case, this is not a new field. I'm not pulling it from the source. It was ingested, it was typed, it was added to the schema, but I'm not, it doesn't work for me. So I'm going to override it completely. I'm going to say what I need here is a geopoint. Okay? And to generate it, I am going to use a script. Let's see if I can get it right. If not, I'll look at my cheat sheet. So the script is going to be in Painless. And it's going to be something like this. Okay, so now I'm going to have to emit two numbers, a latitude and a longitude, for the field to be populated. Now I have it in the document, but it's not of the right type. So I'm going to have to parse it. This is like an emergency fix. So what I'm going to do is I'm going to create a map, a point, which is going to be a map containing two things, the latitude and the longitude. And I am going to use the grok processor. In the grok processor, I'm going to put a pattern. But before we do that, then I'm going to say, extract, after I put my pattern in here, right? I'm going to say extract from the existing value, which is, I can tell the keyword version, which is in the doc values. I can say, give me the location.keyword. I mean, that has the data I need. It's just not in the right type. So I'm going to say, take that value, okay, and then extract that and put it in the, as a map. That's how grok works. It's going to take everything I put in the pattern and turn it into fields in the map, and then I can emit. Okay, so here what I'm looking for is a pattern that's looking for the word location. Okay, it's followed by a space, followed by a left parenthesis, and then I'm going to capture a number. So I'm using grok here, and let's see, the longitude goes first. So I'm going to capture a number in a field for the map type double, so that is going to be the longitude. And then I have another space, and then I'm going to capture another number. This one I'm going to call lat, and it's going to be another double. And then for completeness, so that the grok pattern doesn't fail, I'm going to put the right parentheses. So this should be able to extract into point these two values, which I need to emit to populate the overriding runtime field for location. So if the grok is fine and it does what we hope it will do, pass through location, find the parentheses, capture the first number, turn it into a field in the point map, just a Java map, and the same thing with the latitude, and pull that data from the location keyword, which we know we do have. Then we should have an overriding. Of course, when I use it, I need to use the overridden version, right? So if I use the location, now it says, okay, no problem. Location is actually a geopoint, and it has a latitude and a longitude, and the centroid aggregation can actually do its work. But notice that this is not really true. If you look at your data is still what it used to be. If you look at the original mapping, the mapping still has that field as text keyword, but at runtime, we are actually overriding it, okay, with a runtime field that fixes the type and makes everything work. So let's see how this would work in Kibana. Okay. So what I'm going to do is I'm going to put it in the mapping so I can see it in Kibana. Okay, I'm checking how we're going on time. So I'm going to add to the mapping the runtime clause. I like to repeat things a lot because the first time you see something, you kind of get it. The next time you do get it, the next time you say, this is now getting boring. Then that means you learned it, right? Okay, so I'm going to put it in the mapping. So now I can go to Kibana, and then I can say, hey, let's make a data view. Data view with that. So now I have, I don't need any of that. I'm going to create a data view. And once again, I'm going to call it museums, but the index pattern is actually museums 2. Okay. And here's the data view. Notice that Kibana doesn't know that the location is not really physically a geopoint. The schema actually created an inverted index for it because it's of type text. So there is an inverted index somewhere back there in Elasticsearch land. But as far as Kibana is concerned, it read the mapping of the index, and it said there's a field called location, and it's of type geopoint. So that's my story, and I'm sticking to it. And then when we want to do something like a map, we can actually do that. We can say, hey, create a map, and let's add a layer using points from one of our data sets. So let's go ahead and use the museums, data view, okay? And then we can even, play around with some tooltips, and we have icons. And the set of icons actually have museums, so why don't we use that? All right, so there is our map, totally functional. Thanks to a runtime field that fixed the data in an emergency mode because it was ingested improperly by not setting the schema, or maybe it just couldn't be recognized because whoever wrote the data thought the name of the that you could use the word point, that you could use the word location when what they were supposed to use was the word point. So we fixed all that in a moment using a runtime field. However, it's not there, right? So if I come back here and I do this, I've said, okay, take museums 2, change the mapping, remove the runtime field. Remove the runtime field location. Setting it to null. If I do that, then not only does this cease to work, but then the maps are really mad at me now, right? I get a really obnoxious message saying, what on earth is happening? This was working just a moment ago. So yeah, creating runtime fields and not making them permanent, not moving them to become index fields, which is a best practice at some point, is going to have consequences on whoever downstream is using those runtime fields. So be aware of all of that, and don't do that to people. So let's put it back in the mapping, and let's fix our map. By the way, if you care to know where the centroid is for these museums, if you did want to set up a bed and breakfast and have tourists that want to go to all those museums, it even gets us to a location where there's a nice chalet somewhere in Belgium. So what I would want to do is buy it immediately and then set up my bed and breakfast to cater to tourists that have a pretty high level of culture, right? So here's where, in the maps you saw where the museums were. The Rembrandt Museum, the Louvre, and the Musée d'Orsay. So you couldn't have done any of that without a runtime field. Okay. Then my last demo. By the way, I like doing demos from scratch because then you see everything, including the glitches. So I try not to have everything prepared, although I do have a backup code. But if we can fix it together, then that's a better lesson than just doing it from a totally prepared script. Might as well use slides for that. All right, so let's go back to the students and the instructor. So an instructor has some students, and they took the class, and they had homeworks on music topics like early music, the Baroque, jazz, and they got grades. And then they had to take 3 tests, a midterm, and a final. This teacher is a real, I don't want to use any adjectives, but I don't know that I want to take someone who tests so much, right? Unless the tests are really easy. But anyway, so we have 6 students. I'm going to, first of all, I'm going to delete them. And then I'm going to ingest them so I have some data. And so what the teacher wants to do is, the teacher wants 2 things. Calculate the grades with weights and a scale that the teachers will provide to us. And then they want to keep it at runtime because they want to do simulations by changing the weights here and there and seeing, how many people pass and how many people fail. So even though this should be in the syllabus and should not be changed because it's a contract, this teacher is not that worried about that at the moment. Okay, so let's look at our data. So there are our data. Notice that everything is an array of nested objects. And if you have worked with nested objects in Elasticsearch, you know that our story is horrible, that Kibana doesn't do well on them, and that not only that, they get flattened. The way they get stored in Lucene, which is actually where physically everything gets stored in Elasticsearch, is all this data will be flattened. So there will be a topic field that will have a list of topics, early music, the Baroque, jazz. And then there will be a list of grades, but the relationship between a 98 and early music will be flattened. So the queries that, the standard queries won't even work here. So runtime fields to the rescue yet again. So we have, so what we would like to have is fields that will give us, when we run the query, the numeric grade and the letter grade. And of course, right now we don't have them, right? Now for more advanced logic like the one I'm showing you here, I would not develop the code on the fly. I would actually use the execute endpoint and use dummy data to get the logic right before I use it in an actual index. So this is the solution I want to do. I need a little function. So I'm in this example, I'm showing you that Painless has the full-blown power of Java. So you can do horrible things or you can do wonderful things. And you should make your code readable and encapsulated so that it's portable and all that. So I need a function to calculate from a list of items that have a grade field, the average, and return that. And then I'm going to put the rest of the computation in another function that takes the homeworks, the exams, and the weights and the letter ranges, and somehow puts it all together and gives me back the numeric grade and the letter grade. Okay, the logic is not that important because we all know what this is all about, because we've all been subject to this type of grading, fairly or unfairly. So I would test this in standalone mode before I put it in a runtime field, because in a runtime field now you need to worry about is this picking up the data from the document or not. I'm passing my own test data. So I took the homework from one of the students, and then I asked the teacher, well, what weights do you want us to start with? So for a student that had these grades, the result would be a B with a numeric average of 91.4, which kind of matches the letter ranges, because you would have to have at least 94 point something to get an A. What if we say, what if we lower that to a 90? Okay, well, yeah, it seems to be working. Then I would move my script to the actual search. So now this is the same search we had before, except that now I have a solution for these fields that in the previous search, in this search, there's no such thing. There's no such fields, right? I'll just have the original data and then the name. But what the teacher wants is the name and the grades. So now I have my original data, and every one of those records has the numeric grade, the letter grade, and the name. Okay, and then the teacher can then do the simulations they want to do by saying, well, let's play with the scale a little bit more, like we kind of did. So your code can be, okay, I'm not pulling data that wasn't indexed. I'm not fixing a bad field. I'm just doing a field that doesn't exist, that is fairly complex, that needs some computation. It's a calculated field. It's a derived field. Totally valid use case. It's just something you don't want to you don't want to calculate at ingest time. And in this case, we can't, because the teacher is going to be changing the scale at runtime. They really don't know what the scale and the weights are going to be until they see how the students did, so that they can do the simulation. So in this case, there's data that we don't have at ingest time. So the only solution is a runtime field. But it's pretty elegant if you think about it, except for the fact that now I'm using for loops, functions. So before you know it, you're writing 200 lines of Painless code, and you may make a mistake and turn this into a halting problem, like an endless loop, or a bottomless recursion that destroys the heap space. So yeah, you're writing code. That's the message. That's why I wanted to show you. There's a lot of code even in this simple problem. You are a programmer. You have to have the skills and disciplines of a real programmer, including testing, debugging, source control, and all of that, before you put it in production and affect all kinds of people by your little script here. In Kibana, we used to have a warning when you added a scripted field that says, are you sure you want to do this? Do you know that you can have an impact on the cluster? Which to me meant, why do we even put that in Kibana, right? Why do we give that a Kibana analyst that doesn't want to have that kind of power? Why do we make them have access to something that can break everything? All right, so enough of a rant. So what I'm going to do is I'm going to promote. I'm not promote, but I'm going to move the script from a runtime fields clause to a mapping, so that then I can simplify the searches and all that, and then so that Kibana can access it. So now I can do the same thing, and here are my students with their grades. And not only that, now I can ask questions, right? So I can see who got how many grades. I can search, who are the A's in the class with a query. Notice we're doing this on a field that does not exist. In fact, like I said, the autocomplete doesn't really know about these fields. It says, what are you talking about? The autocomplete is great on this, but it doesn't it doesn't have that. So who got A's? Apparently no one. Who got B's? A bunch of people. Who got C's? A bunch of people. So we can now do aggregations and and searches, and then we can also create a data view up here, which is probably where some people would mostly use the results of our work. So let's create a data view for students. And I don't want to save this. I'm going to create a view for my students. And in the data view, I will have everything that came from the original data set plus any runtime field. So I have a letter grade, which is a keyword. I have a numeric grade, which is a double, and those don't actually exist in the data. But you can go to Discover and say, I want to see my students. Let's go to that view. And here's your students, and you can populate that. This one, let me remove it. All right. Now one last, well, actually, I'm going to, once again, if you make changes on the Elasticsearch site, so let's say you change the scale, and the teacher says, I'm in a real bad mood right now. No one below a 91 is going to pass. These are my thresholds. I mean, I'm talking seriously bad mood, right? And then, the innocent user of Kibana was looking at a screen with passing grades, and now everybody got an F, right? Which is really, again, what we do on the mapping side has consequences. Let me restore that to a more reasonable grading scale. One last use case I want to show you is that if you're in Kibana, you can actually say, well, I want to add a field. Okay, after we restore sanity, I want to add a field because I would like to know what the average grade looks like if I multiplied it by 2, or maybe by increase it by 10%. You're doing this on the Kibana side, so you can click on that field here. So this is a runtime field created as part of a data view in Kibana, which is going to be a runtime mappings clause added to a search, right? So, but in Kibana, you can name it. So I'm going to call this one grade doubled. Okay. And it's going to be of type double. And this, but I need a script. This is the part that I was saying. Why are we making Kibana analysts if they're not coders? Why do we make them find out all about all this syntax? Where they have to go to, okay, so where is it? It's in grade letter. And I need to get the value. And a lot of people, don't have any interest in doing this, okay? Unless you're a programmer. And then there's an error. And where is the error? Cannot apply. Oh, because I'm using the letter. I am my own worst enemy, but that's the mistakes people make. What is great about the custom field in Kibana is that it gives me a preview. So I should not go beyond this point unless I can do it error-free. So, I'm all happy because I got my script working right, and it's going to show up on the view. I can add it. Here's the grade doubled. Okay. And then once again, somebody on the other side says, well, we're done with that. I just want to get rid of that that field completely. So they go to they go to the mappings. My last bit of code for today, but it's totally destructive. I'm going to go to the mapping, and in the runtime clause, I'm going to say, I don't need this field at all anymore. Well, maybe I don't, but that's not going to be necessarily true for the world, because if I go to Discover, now consequences are really bad, right? Because not only did I break a lot of things, but I mean, some fields don't even exist, but the Discover now crashed because now the script that we wrote in Kibana doesn't have a way to work because there's no such thing as grade.numeric. So yeah, so immediately you would go back and scream at who took that field out of commission. You don't do things like that. We got to run the project as a project and all that. Anyway, so all good. So to finish off, let's just review some of the things I've been saying and maybe preaching about. Nobody likes to be preached at, but it's, I mean, this is a great tool, but you need to be aware of what it takes to use it, right? So the runtime fields are calculated for every document that is a result in a search. Okay, so it's better if you index the field because it's already there. But you say, no, this field I don't have. I need, I need. You may have good reasons. If you must create a runtime field, understand the complexity, both time and space of your code. If you don't know what that means, look it up. It's important. I mean, you are actually, in the most practical sense, needing some theory of what is an efficient algorithm again? Why was bubble sort not a good algorithm for sorting again? Okay, so those, why should we do a binary search instead of a linear search? Why would that be? Well, because your query, your very practical query that's powering a dashboard, is now a lot slower if you use the wrong thing. Okay. Also, keep in mind that you write code, you own it, right? We're going to keep changing Elasticsearch, and we do that all the time. Every minor release changes things. We don't feel any responsibility to be backward compatible with your code. It's not going to happen. So you're going to have to be keeping up with any updates to your code as you upgrade the stack. Some best practices are, do use runtime fields to control mapping explosion, to save space. When you need a field that's calculated, use it for prototyping to explore like an unstructured field. Use grok to say, well, what if I extract these 3 fields? Would I need to do that? And then you can promote them to a permanent field. Now, since we're adding latency to a query, you could always say, well, let's use asynchronous searching. Okay. So yeah, I mean, they're meant to be used. In fact, there were some of our competitors that, their claim to fame was, well, we have Schema-on-Read. Well, guess what? So do we, and they have the same problems we do, and that is there's a decrease in performance. That's one of the reasons we always said, we have them, but let's not use them. But now we have them in a big way because they're like regular fields. They work the same. You can use them for aggregation, searching, and sorting. There are a bunch of things I didn't cover because we only have 1 hour. So index for the fields that you frequently search on, make those be indexed fields, not runtime fields. Okay, because then your searches will go for those first. Then the search will be fast. And then once the results are obtained, then the calculated fields are applied. So that's a good way of doing this. If you are using scripted fields, scripted filters, or scripted sorts of the old style, consider promoting them to runtime fields because it's the same performance, but these are real fields. The other ones are not. The other ones are just at the last phase of a query, you do some calculations and you put it in the results. These things are fields that you can query, aggregate, and sort on. So these are real first-class schema citizens. Okay, and then keep in mind that runtime fields in Kibana are really queries using runtime mappings. Also keep in mind that in Kibana, Kibana is going to pay the price, and so will any other client, of any changes you make to the mapping. So if they had already done a lot of work with visualizations and queries, and you say, no, I think we need to change things, you are going to have an impact downstream. And then finally, someone's going to have to look at your code even long after you leave. So please write readable, encapsulated, and efficient code. And the documentation is a great resource. It's got tons of examples. Then we also have blogs, tutorials, and meetups, and we're going to keep doing that because the runtime fields is a work in progress. It's not complete yet. There's some types I didn't even talk about today. And we're working on a class on runtime fields that will be available sometime in 2023 that will have a lot more, tons of demos, practice labs, and a lot of code downloads. This meetup is mostly to make you aware. But if you really want to learn it, then keep an eye out on the on-demand channel, for subscribers. And this should be a fun, very practical, very relevant topic. Don't forget to join the user groups, and don't forget to be a contributor. speaker. We love hearing from our customers, our employees, our friends, and family, and everybody. So that's it. Thank you very much.
Perfect.
Oh, right on time.
Thank you. Yeah, right on time. Awesome, Enrique. You did amazing. It doesn't look like there are any questions, just some support for you in the comments. So
appreciate it.
Very good. Again, thank you everyone for joining. Like I mentioned at the beginning of this live stream, if you're interested in presenting, we welcome obviously members of the Elastic team, but outside of the company as well. We love hearing from people in the community, customers. So with that, that's all I have. Any last words, Enrique, before we end the stream?
No, just thank you for allowing me to present, and thank everybody for coming.
Thank you. Take care, everyone. Bye.